Now that we know how to find the domain and vertical asymptotes of a function, we want to find the horizontal asymptotes and the range. One thing I do want to start out with though, we didn't draw this in the last one, but if you recall, when we have a rational function, we have a graph, the parent function y equals 1 over x, if you recall, looks like this, because x and y cannot equal 0. And so therefore it approaches but never actually touches it. Now, if you recall back to chapter 1, we see here in this first one of y equals x over x minus 1, this here is inside, therefore it makes it a horizontal shift, and it's the opposite, so we're actually going to be right 1 unit. What that means is it takes our our whole graph, including this vertical asymptote, and shifts it over 1 unit, which means that my vertical asymptote will now be here with a graph which is now here. And I want you to be aware of that because you will see some on your homework that are saying +3 out here, which would mean that this is a vertical shift up 3, which would take that y or intercept of y equals 0 and it'll shift it up 3, which would mean that you would now have if we had this full thing together, it would be here that you would have your shift. And I know that's a lot to look at, but I just want you to realize that. So if you get something like that, you can find common denominators and go that route, but this is a route you can also take a look at for it. So moving on, we want to actually find the horizontal asymptotes. And so the first thing that we need to do is we need to look at the degrees of the numerator and denominator, represented by n and d. As you can see, in my numerator, I don't have an x value, which means it's like I have x to the 0 power, or degree 0. And in the bottom, I've got this x, which means I have x to the first power, or a first degree problem. Now, if we have in this, as is the case here, where the numerator's power degree is less than the denominators, then we have a horizontal asymptote at y equals 0. So I'm going to mark that down, that I have a horizontal asymptote at y equals 0. Now, when we talk about the range is going to be written in the exact same format as was the domain, except now we're talking y values. So we've got a bracket, and we say that all y values such that we have everything but y equal to 0. So y cannot equal 0 because that is an asymptote where it doesn't touch. Now we move to this next example, which is the case here. If the numerator's power equals the denominators, then the horizontal asymptote will be at y equals a over b. So I can see here that I have an x squared and an x squared. They match. And what we mean by a over b is that if we look at this as this is the function p of x, and this is the function q of x, then what we need is the leading coefficient for each one. We divide it and we get that value. So for our horizontal asymptote, we have that y is going to equal 2 over 1 because we're looking at the highest power leading coefficients, which are 2 and 1, which means that my horizontal asymptote is at y equals 2. Likewise, that means that my range is going to be all y's such that y cannot equal 2. And then we have our range. Now, one example that I don't have here, but we can take a look at with this next one, If the numerator's degree is greater than the denominator's, then there is no horizontal asymptote. So if we look at this next one, if we factor this out, we get x plus 3 times x minus 3, and we get x minus 3. Now before we get into that, I see here we've got a squared and we've got a power of 1. The numerator's power is bigger than the denominator's, which means there is no horizontal asymptote. Now, one of the things we want to talk about, you hear wholes we defined earlier. If both the numerator and denominator will equal 0 for a particular value of x, then there is a whole. As you can see, I have an x minus 3 in both the numerator and denominator. In 8.1 to 8.3, we learned that these can cancel each other. This means I have a whole at x equals 3 in my graph. So what my function now reads though with canceling is that f of x equals x plus 3. That means that I have a y-intercept at 3 and I have a slope of 1. However, I have a whole at 3. So that means if I go at 3 up to this point, I actually have a hole, and I'm going to draw that hole. What I will actually do is I'm going to erase that spot so I can draw it in better. So I have a hole, and what that means is all points leading up to it are part of the solution, but that number does not exist. So now what I want to do is actually put this all together. I want to find the domain, vertical asymptotes, horizontal asymptotes. I want to also find range and any holes in the function. So if we look at this one, my domain, first I'll find my vertical asymptotes. I see that I have a vertical asymptote because x minus 1. That means that at x equals 1, I have a vertical asymptote. Therefore, my domain means that I have all x values such that x cannot equal 1. Now, horizontal asymptotes, I see that my values are equal for the degree. So that means that y is going to equal my coefficients, which is 4 over 1. So therefore, y equals 4 is my horizontal asymptote. I don't have, even though I can factor this into 4 times x minus 3, there's nothing that can cancel, so there's no hole, so I'm going to put none. The last piece that I don't have written here is going to be my range. And recall, because the horizontal asymptote is y equals 4, it is all y values such that y does not equal 4. Moving on to the next and last example. Here we have f of x equal to x minus 2 over x squared minus 1. Well, I see that this factors. We have x minus 2 on top, x plus 1 times x minus 1 on the bottom. Nothing can cancel, so we know that there is no hole. I see that we have values for which x cannot equal at -1 and 1, so I have vertical asymptotes, at x equals 1 and x equals -1. Therefore, my domain states that all x values except that for where x not being able to be equal to 1 or -1. Now, horizontal asymptotes. I look and I see that my degree is bigger on the bottom. That means I have a horizontal asymptote at y equals 0, making my range all y values such that y cannot equal 0. Your job now is to go ahead and complete these 3 U-try problems. And I do want you to add in for each of these to do the range too for all 3 of them. And bring your questions with you to class tomorrow.